So let us look at the what? The experiment of gold leaf electroscope. As what? Experiment of gold what? Leaf electroscope. So if we are talking about what? The experiment of gold leaf electroscope, it's comprised of three experiments. According to the gold leaf electroscope definition, I said it's a device that's used to detect the what? The existence of what? Of charge. You can use gold leaf to detect the nature of what? Of charge. You can use the gold leaf to detect the what? Magnitude of what? Of charge. So as a result of that, the existence of gold leaf, the experiment of the gold leaf electroscope exists in what? In three forms. One, the experiment to use the gold leaf to determine the existence of charge. The experiment that you can use to what? How to use gold leaf to determine the nature of charge, and how to use gold leaf to determine the magnitude of what? Of charge. The first experiment now is what? To determine the what? The existence of what? Of charge. To determine the what? The existence of what? Of charge. That's what? The first one is to what? To determine the existence of what? Of charge. So this is the first experiment of what? Of gold leaf what? Experiment. Sorry. Do you still remember that what the gold leaf electroscope is look like this? We have the brass and we have a what? A stem. This is the leaf. And here we have a metal case that surround the what? The gold leaf. Abi? Yes. If I want to use what? Gold leaf to determine the existence of charge. The gold leaf, assuming is what? Must be charged. This gold leaf is contain negative what? Negative charge. This is a charge electroscope. And I want to what? Confirm whether this marker is a what? Is a charge body. If I place the marker on the what? On top of what? Of this brass of what? Of gold leaf electroscope. If this marker is contain charge, either positive charge or negative charge, the leaf you have here, the two leaves we have here, they will what? They will move. They will what? They will move. If the leaf we have inside the electroscope what? Move, either by what? Converge or by diverge, it tells us that what? This marker is contain charge. The existence of charge can be what? Determined in an electroscope, charge electroscope, by placing the what? The test body on top of the brass cap of what? Of the gold leaf. The movement of this leaf tell us that what? The test body has what? Charge. But if you place the what? The test body on top of what? Of electroscope, and this leaf remains stationary, it tell you that what? This body does not have charge. So in existence of charge, now the what? The gold, the what? Gold leaf move. This leaf will what? Will move if there is a charge. If there is a what? Charge on the test body. As I said now, if this test body contains charge, the leaf will what? Will move. But if the test body does not have charge, the leaf will remain stationary. So the gold leaf will move if there is a what? A charge on the text body, but remain stationary if the what? Test body is neutral. So when the test body is what? Is neutral, the leaf what? Will remove, will remain stationary. That is what how we can use the gold leaf to test for the existence of charge. Take now, if this, look at this gold leaf now, this electroscope is a negative charge electroscope. If I place my what? My test body on top of it, the leaf will remain stationary. It tells us that what? The test body I placed on top is what? Is neutral. But if I place my test body on top of the what? Of the brass, and the leaf here move like this, it tells us that what? This test body is a charge body. But if this test body is a charge body, I want to know the kind of charge that I can have on this test body. Is this positive or negative? That is what we call what? The nature of what? Of charge. The second experiment. To what? To determine the nature of what? Of charge. So, if the leaf is moved, it tells us that what? The test body is what? Is a charge body. So, let us look at it. What happened here? Here, the gold leaf move closer. The gold leaf move what? Leaf move closer. When the gold leaf move closer, simply means what? Attraction. What do I call it? Attraction of the charge. When the gold leaf move closer, is what? Attraction of what? Of charge. If the what? The gold leaf move closer, who is what? If the test body is opposite, what? Opposite to the charge on the electroscope. Electro what? Electroscope, which is what? Brass cap. Hello? If the gold leaf will move closer, if the charge on the test body is opposite to the what? The charge on the what? Electroscope. That's the first case, yo. Let me put stop here for the first point. On other hand, on what? On other hand, on other what? And so here, it what? It move wider. It move what? Wider. The wider here means what? Repulsion. It move wider simply means what? Repulsion. If the charge on test body is the same as the same as the charge on electroscope. Charge on electroscope. Do you understand this? Let me use diagram to explain it better. Look at this experiment here. This is a brass. Here we have what? A stem. This is what? This is the second diagram. Look at it now. Yes. This is a what? The gold leaf electroscope. I'm not introducing a what? A test body here. And look at the test body here too. Zoom the charge we have on the test body here is negative. And the charge we have on the electroscope is positive. But here, the charge we have here is positive, and the charge we have here on the test body is also what? Positive. So this what? We call it what? This what? We call it test what? Test body. This is also called what? A test body. Look at what? The charge we have on a test body is different from the charge we have on the what? On electroscope. They are opposites. Abi? So when the charge we have what? In the test body is opposite of what? The charge we have in what? In the electroscope. Look at this leaf. This is what? The original position of the leaf. This is the original position of the what? Of the leaf. So between this test body now, you observe that what? They will attract what? Each other. Test body and the brass cap. And here, we all know that what? The negative charge, what? The negative charge will come down to what? To this side. So since this is positive, negative, this is what? A positive. The leaf we have here, they will what? They will attract, they will converge. Because there will be the what? I said it here, If the test body is opposite charge to the what? To the electroscope, what happens to the leaf? The leaf will move what? Closer. So this is the original size of the what? Of the leaf. This leaf now what? They will move closer like this. So here now, the what? The leaf, the gold what? Gold leaf here, move what? Move closer. When it move closer, we call it is what? It is converge. Is what? Converge. So when the charge on the test body is opposite to the charge of electroscope, the leaf will what? Will come together. They will move closer due to the what? Attraction, or we call it what? Converge. But here, the charge we have on the test body is the same thing with the charge we have on the what? On electroscope. So we have on electroscope, what will happen here? These two will experience what we call a repulsion force. When it experiences repulsion force, the what? The leaf will what? Will diverge. The leaf will move like this. It will what? Move away from each other. The leaf will what? The what? Gold what? Leaf move wider. Move what? Wider. What is move wider? Simply means what? What? Diverge. So that is when the what? The test body is placed on the what? On a gold leaf electroscope of positive charge, and this test body is unknown, and the leaf is what? Move closer. It will tell you that what? The test body is opposite of what? Of this positive, which is negative. But if the leaf, gold leaf is has a positive charge and the test body is unknown, we now place it on the what? On the positive electroscope, and the leaf what? Move wider. It tell you that what? The test body have the same charge with what? With electroscope. That is what the result of how we can use what? The gold leaf, or to determine the what? The nature of a charge. So the next thing is what? I will put this experiment on a table now to summarize it. And that's what? The result of this experiment are summarized below. We have charge on test body, charge on a what? On a test body. We have charge on electroscope. Charge on what? On electroscope. Next one is effect on gold leaf divergence. So yeah, let us look at this thing now. If the charge on a test body is positive and the charge we have on electroscope is what? Is negative. The charge on the test body is positive. The one on the electroscope is what? Negative. Like here, we have negative, positive. The leaf will what? We attract each other. They will move closer. So here we have positive, negative. What happened to the effect of the leaf? It will be what? The leaf will what? Move closer. When the leaf will move closer, we call it what? Is converge. The leaf is what? Converge. That is, move what? Closer. They come together. But if the charge on the test body is negative, charge on electroscope is positive, what will happen? The leaf will also what? They will be the what? Repulsion. No, they will be the what? Attraction. The leaf will what? Will converge, which is also what? Closer with each other. But in a case of the charge on the test body is positive and the charge on what? Electroscope is also what? Positive. Like the one we had there, what will happen to the leaf? It will be what? Diverge. They what? Diverge. They will move away from what? Each other, which is what? The leaf what will move wider. Move what? Wider. So again, if you have a situation in which electroscope is what? Negative, this is also what? A negative. And what will happen to the what? To the effect on the what? On the leaf, you know, the same charge, it will what? Repel. It will experience diverge, which is what? It will move what? Why what? Wider. But if a test body has a positive charge, a test body has a what? A positive charge, and the leaf, the electroscope is what? Is neutral. What will be the what? The effect on the leaf. So it will what? Converge. See, please, if we say something is converge, it's same thing as what? Decrease. The what? Decrease. That's I say what? Converge means what? The leaf is moved what? Closer. The anything converge simply means what? Decrease. Please note it. Anything diverge simply means what? The leaf is what? Increase. Diverge means what? Increase in leaf. Diverge means increase. Converge means what? Decrease. So when the what? The test body is neutral, the test body is what? Is neutral. Sorry? When the test body is what? Is negative. and leaf is what? Is neutral. The gold leaf electroscope is neutral. You still experience what we call what? Converge, which is what? The leaf will what? Decrease. But when the test body is what? Is neutral. Test body is what? Is neutral. You have a neutral what? Test body, and the gold leaf is what? Is positive. It will be what? Diverge. Which is what? In what? Increase. So that is all about what? The experiments of the gold leaf electroscope. This is how we can use what? Gold leaf to determine the nature of what? Of charge. So the next thing that we are going to treat now is what? Is distribution of what? Of charge. Distribution of what? Of charge in a metallic what? Conductor. So the charge is always the thought of what? Distribution of what? Of charge. That's my new subtopic. Distribution of what? Of charge in a conductor. See, the charge is always uniform distributes. Charge is uniform distributes in a regular shape. Charge always distributes uniformly in a regular what? Shape. Such as what? If you have a shape of what? Of a sphere like this. And mind you, we cannot find charge inside a conductor. Charge can be found at the surface of what? Conductor. This is a what? A sphere. So if charge want to distribute here, the charge is what? Is distribute on the surface of what? Conductor. Uniform what? Uniformly. The charge can never be distributed or can be found inside the what? A conductor. Charge can always be found at where? At the surface of what? The conductor uniformly. You can see that what? This is a what? A uniform sphere. The charge is what? Is distributed equally or uniformly in a uniform shape or in a regular shape. But in the case of what? We have shape of triangle. This triangle we have there, the distribution of charge in the triangle is not what? It is not uniform. Because the sharp corner here will contain more charge than this normal side because of the what? Of the small surface what? Area. So here we have what? The charge here, distributed uniformly here. But at this point, look at the charge now. Charge is more concentrated at a sharp what? Sharp corner. Due to the what? The small surface what? Area. This is how charge will distribute on what? On a triangle. You observe that what? The sharp end here contains what? More charge. Or this, if you have what? A shape like what? Like this. Which area of this shape will contain more charge density? Here, this sharp what? End here. So the charge here will be like this. So in this distribution of charge now, you need to note two things here. The first thing is what? The charge can never be what? Found inside the what? Conductor. The charge is always distributed uniformly in a regular shape. But the charge distributed uniformly on what? On irregular what? Irregular shape. So, and a more charge can be found at the what? At a sharp corner due to the what? The low surface what? Area. So in this shape now, you can see that what? This side contains more charge density. Likewise, in this triangle, that is what we call what? Charge distribution. And the last thing that I will need to add here is a what? There is a particular device called proof plane. What will I call it? Proof plane. So proof plane is a device in what? This is a what? A device that used for transfer of charge from one body to another. And a proof plane is look like this. This place is what? Is what? Insulator. So if they want to transfer charge from one body to another, we will use what? What? Proof plane. So that is all about what we call electrostatics. And the next aspect we are going to treat now is what we call what? Electric field.